recording. All right, polar coordinate system. Polar coordinate system is a plane with a point O called the pole. So you have the origin, really, it's the origin. So there's the pole. And a ray from point O to a point, the polar axis. Each point P in the plane is assigned polar coordinates as follows. R is the directed distance, so R is the distance, R, comma, and from O to P, and theta, I don't know why it kind of got squished up there, is the directed angle whose initial side is on the polar axis. So in other words, theta, and they're saying that it's kind of, it's unit circle measurements, right? So counterclockwise is positive, clockwise is negative. As in trig, we measure theta as positive, and that's what this tells us, that it's the same as our unit circle, positive and negative, right? Point A can be located by using the Cartesian coordinate system or polar coordinates. So we can find this point by going 1, 2, 3, 4 over, and 1, 2, 3, 4, 5 up. So 4 over and 5 up. And we have what's called an x and a y, made up of vertical lines and horizontal lines from 0, 0. But we can also find this point by saying, well, it's on a circle of radius something. So radius something. But if we just say it's on a circle, that doesn't pin it down. We know it's up here, but if it's just on a circle, it could be anywhere. Well, now if we say, well, it's on a circle with this angle, with that angle, now that becomes a unique point. There's no other point with that combination, with that radius and that angle. There's no other point that has that. So plot the points with the given polar coordinates. 2 and pi over 3. So 1, 2, and pi over 3. That's about, let's say, right there. Negative. We go along 3 pi over 4, but in the opposite direction. So we're on a radius of 2, for sure. There's negative 2, but 3 pi over 4. 1, 2, there's 3 pi over 4, but instead of going up here to 2, we go back the other way in the opposite direction. So there's negative 2, 3 pi over 4, opposite direction. One, 2, 3. 3, but negative 45 degrees. That's down here. So I did one where they're both positive, one where the R is negative, one where the angle's negative. So that covers pretty much everything, except for the negative, I guess. Questions on any of that? Going in the opposite direction, going the opposite angle. All right, pretty straightforward. Each polar coordinate pair determines a unique point. However, the polar coordinates of a point P in the plane are not unique. What does it mean by that? And then I kind of explain all that. Let's just jump down to here and actually do the example. Reading all that it doesn't make any sense. If the point P has polar coordinates 3 pi over 3, find 3 additional pairs of polar coordinates for P. If you go from negative 2 pi to 2 pi, you should be able to find 4 coordinates for one point, for every point. We'll do 2 positive 3s and 2 negative 3s. And we should be able to find 4 coordinates for the exact same point. First one is 3 pi over 3. So 1, 2, 3, and here's pi over 3. So we're going to find 3 other coordinates for that point. There's the given one. Well, we went positive 3 with a positive angle. How about positive 3 with a negative angle? Instead of going this way, let's go this way. Let's go all the way around to here, which would be 1, 2, 3, 4, 5. Negative 5 pi over 3. If we go here, 1, 2, 3, if we can get to there, then we can have a negative 3 and it'll go in the opposite direction. So let's get there in a positive direction and a negative direction. So here's the negative. negative 1/3, negative 2/3. So negative 3, negative 2 pi over 3 gets us this point again. We're right there. Because when you get there, you're going to go in the opposite direction. It's up there. All right, and then the last one here. 1, 2, 3. We want that point, but we want to get to here. 1, 2, 3. We want to get here. We went in a negative direction. Now we just have to get to there in a positive direction. 1, 2, 3, 4 pi over 3. There we go. So you should be able to have 2 positive r's and 2 negative r's. 4 coordinates for the same point. When we use both polar coordinates and Cartesian coordinates, the pole is the origin and the polar axis is the positive x-axis. By applying the trigonometry, we can find equations that relate the polar coordinates and the rectangular coordinates together. So in other words, we're going to convert back and forth. Let the point P have the polar coordinates r theta and rectangular coordinates. So here's rectangular, here's polar. Here's your tools that you have at your disposal to convert between the two. X is the same as r cosine, y is r sine. R squared is the same as x squared plus y squared, and tangent's always sine over cosine, y over x, opposite over adjacent. It all means the same thing. Find the rectangular coordinates of the points with the given polar coordinates. So this is a r, not a theta, but an r rather. This is an r, that's a theta. So the x and the y are 3 cosine of 5 pi over 6 and 3 sine of 5 pi over 6. Five pi over 6. That's over here. That's negative square root of 3 over 2, 1/2. So 3 times negative square root of 3 over 2, and 3 times 1/2. Not much you can do there. We could turn them into decimals, but we don't need to do that. You could have degrees also. No different though. 2 cosine of negative 225, 2 sine of negative 225. So negative 225, here's negative 180, and another 45. That puts you right here. So 2 times negative square root of 2 over 2, 2 times square root of 2 over 2. So the 2's cancel. I'll get out of the way here in a second. There we go. There is the x, there's the rectangular coordinates for that point. So the 2 tools that we used were these 2 right here. There we go. When converting rectangular coordinates to polar coordinates, we must remember that there are infinitely many possible polar coordinate pairs. You could just keep going around the circle. You could have an infinite amount of coordinates for one single point. Just keep going around the circle. Find 2 polar coordinate pairs for the points with given rectangular coordinates. So the point negative 1, 1. Negative 1, 1. Well, I don't really need the tools for it, but what if I didn't know that this was at 3 pi over 4. I had to think about it a little bit. 3 pi over 4. The r is, we get r by doing r squared is equal to x squared plus y squared. And the angle is the inverse tangent of y over x. So there's the tools, right? So we want the square root of 1 plus 1. Right, if we square both of those. And then we want the inverse tangent of negative 1. This is the square root of 2. With this one, the actual answer for this is negative pi over 4. This is actually negative pi over 4, but that's not the one that we want. That tells us that we're down here. We're not down here. We got to add pi to that. In other words, it's 3 pi over 4. So you have to know where you are in order to answer some of these, especially with inverse tangent. That's one of them. How could we get another one? We could still have square root of 2, but instead of going positive, we could go negative 1/4, 2/4, 3/4. There's 4/4, 5/4. So negative 5 pi over 4 is another coordinate for the same point. Just go the other way around. I'm not going to do it, but we could do 2 more with the negatives. One positive angle, one negative angle. 3, 0. 3, 0. Well, I don't really need the tools for this. It's on a circle of radius 3 with 0 radians. So it looks like it's the exact same thing. And of course, they're the same numbers, but they mean 2 different things. This is an x of 3 and a y of 0. This is a r of 3 and an angle that's 0. The other one could be 3 and 2 pi. Just go all the way around the circle. We could have 3 and negative 2 pi also. That's another one. Convert the polar equation to rectangular form and identify the graph. What do you know about cosecant? Anything? 1 over sine. Oops, that looks like the same thing. R equals negative 2 over sine of theta. Now what we're trying to do is get this to say something with x or something with y or something with x and y. So if we multiply sine over, r sine, if you look at your tools, right here, r sine is the same as y. So y is equal to negative 2. And that's a line. It says identify the graph. It's a line. On letter B, we have to get this to say one of our tools. And one of the tools is r cosine. But I can't just multiply the right side by an r. I got to multiply both sides. So r squared is equal to negative 4r cosine of theta. So the trick on this one to get one of the tools is multiply both sides by r. R squared is x squared plus y squared. And r cosine is x. Now that is a conic. That is more precisely a circle, but we don't leave them like that. We add the 4x over and leave room to complete the square. So we add it over, leave room to complete the square. That's how we treated conics in honors pre-calc. 4 divided by 2 is 2. 2 squared is 4. So this is x plus 2 squared, because that factors into x plus 2x plus 2. Plus y squared is equal to 4. Don't turn the page yet. I'm going to talk a little bit more about this. This is calculus. It's not pre-calculus, so we're going to talk a little more. What did I say this was? And you know what it is. It's a circle. What's the center? Negative 2, 0. What's the radius? 2. All right. So I have a circle with a center of negative 2, 0 and a radius of 2. So that's up here, 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 and here. Right? Everything good? Look good? What do you associate cosine with, x or y? It's x, right? It affects the x. It kind of means the x. So does it make sense that negative 4 cosine would be off to the left over here along the x-axis? Seems reasonable, right? Look at that circle and tell me about the number 4. What is it? It's the diameter, isn't it? It's the diameter of the circle. So that 4 cosine, that 4 does not give the radius, it actually gives the diameter. So off to the right, graph this one. Without converting it, could you just graph it by what we talked about? That's what I would like you to do. That's what I'd like you to be able to do. And maybe I didn't give you enough info, or maybe you're just not catching on. That's okay. Circles are rather hard to draw, actually. You would think they're easy, but they're not. All right, here's what I'm getting at, if you kind of caught on. 1, 2, 3, 4, 5, 6. We have a diameter of 6. But sine, I think of y. It affects the y. This is going to push the circle up along the y-axis. 1, 2, 3, 1, 2, 3. Here's the center. And it probably looks something like that, right? Make sense? So there's a little preview of what we're going to do on Monday. We'll talk about this again on Monday. But this provides us an opportunity to talk about it one more time. All right, let's go the other way. What does the toolbox say x is the same as? R cosine. But if we look at the polar graphs that I gave you, the polar equation, they all say r equals. R equals, R equals. So we want this to say r equals. So we can divide by cosine on this one. And we don't usually leave it as 1 over cosine, it's secant. So 5 secant of theta. That's the answer we're looking for to convert x equals 5 into a polar equation. Then over here we do something similar. 3r cosine plus 4r sine equals 8. That's what the toolbox tells us we can do. It says that they're equal to each other. Well, how are we going to get this to say r equals? What does your intuition tell you? Yeah, factor an r out, right? Now this one's a little bit more ugly, because all we can do now is just divide this over. And that's it. I mean, that's all you can really do on that one. You can't turn it into secant and cosecant because of that plus. If that plus wasn't there, it was times, then we could change it a little bit. I find this kind of interesting. And I don't know how Desmos makes any money because it's all free, but they must find a way. Do I have it open? Yeah. What was our answer? Was it 8 over? R equals 8 divided by 3 cosine, hold on a second, theta plus 4 sine theta. Did I not type it? It's so tiny. How come? What happened? What is it? Oh, okay. Thank you. There we go. Hey, look at that. A line. A line drawn from sine and cosine. I think that's kind of cool. Looks like a y-intercept of 2. Does that seem reasonable? What if we divide by 4, right? Y-intercept of 2. What's the slope going to be? Negative 3/4, right? Negative 3/4. Does that seem reasonable? Down 1, 2, 3 over 1, 2, 3, 4. There we go. Bang. It works. It works. It's the same. This one, you could do what I did up here and put r cosine in for x and r sine in for y. You could do that right away, but I think you'd have to write a little bit more and it might be a little harder. So let's do the algebra first on this one. Squared plus 8y plus 16 is equal to 17. So we FOIL it out. That's what I recommend you do up first on this one. Don't plug it in first. Because now we have this right here. This would have been r squared cosine squared and r squared sine squared, but this ends up being r squared, right? R squared. That's r squared. Now we can plug in 2r cosine. If I go 16 plus 1 is 17, minus the 17 over, I know that piece is equal to 0, and then plus 8r sine of theta. We have to get this to say r equals. If I can get it to say r squared equals 2r cosine theta plus 8, not plus, minus, because I'm minusing this over, minus 8r sine theta. And you might be tempted to square root, but we got r's on the other side, so let's just divide everything by r. Minus 8 sine theta. Doesn't this, if I start at 0, 0, doesn't this push the circle, 1 to the right? And so we're going to push 1 over to the right because the cosine affects the right. But then we're going to go down 4. But sine it affects the y, and it's minus, so it goes down. You see the relationship, at least a little bit? Now, I'm not telling you should be able to look at this and get this. That's not what I'm saying. Just saying there's a relationship there between up and down and or right and left cosine, up and down with sine. Let's plot the point and then give a corresponding rectangular. So this is an r theta. Let's plot it. We're going to go along 5 pi over 6, but we're going to go backwards. So 1, 2, 3. There's the point. And then negative 3 cosine of 5 pi over 6 and negative 3 sine of 5 pi over 6. Now, supposedly when I do this, this point is going to put me down in the 4th quadrant. That's what we're saying. We've located the point. So negative 3 cosine of 5 pi over 6 is negative square root of 3 over 2. And sine is a half. So it ends up being 3 square root of 3 over 2, which is positive, and this ends up being negative 3 halves, which when you graph that, there's a positive, and then the negative does that. So it does put you in the 4th quadrant when you have that negative r, and you're up in the 2nd quadrant. I like B. B's kind of clever. It's on a circle of radius 5, and it says the inverse tangent is 4/3. So we know we're on this circle somewhere. I don't know where we are. We're on there somewhere. How are we going to locate where we are on that circle? What do you think? Yeah, very good. Isn't tangent y over x? So we're on the point 3, 4. Now, if we're on the point 3, 4, do we get a radius of 5? Sure, it's a 3, 4, 5 right triangle. So I need to go along here until I get over to 3 and 4. It's somewhere they have to match up. Somewhere about right there. There we are, because the x is 3, the y is 4, the hypotenuse is 5. That's exactly what it says. It says we have a radius of 5, which ends up being the hypotenuse of this right triangle. Kind of a clever way to ask it. Letter C might be a connection you've never made before, possibly. I know that I'm on a circle of radius 1, but I need to go to 7 pi. Well, if this is 0 pi, over here is pi, this is 2 pi, and this is 3 pi, and then this is 4 pi, and this is 5 pi. Isn't this the odd side, and this is the even side? Right? So negative 1, 7 pi. So we're over here at 7 pi, but at -1. So we're right there, which is the 0.10. There's the point. There's the x and y. So it doesn't matter if they give me 137 pi. I just know there's an odd side and an even side. I don't have to count to 137. In 3 and 4, plot each point with a given rectangular coordinate and find 2 sets of corresponding polar coordinates. Square root of 3 has to be close to 2. It's 1.7-ish. So negative, I don't know why it's not going anywhere, negative square root of 3, negative 1.7, negative 1. So we're down, let's say right there. Why won't my calculator go away? See you later. 2 sets of corresponding polar coordinates. Well, I need to know what's the radius of the circle. So for A, I need square root of, if I square this, I get 3. Square this, we get 1. Oh, square root of 4, so radius of 2. That's handy. But the angle is the inverse tangent of sine over cosine. Inverse tangent of y over x. -1 over negative square root of 3. Now I would put this on the non-calculator part of the test. I put this on the non-calculator, this on the non-calculator. I do not know what the inverse tangent of 4/3 is. That would be a decimal value. But keep in mind that sine, cosine, and tangent are ratios. They are value. They'll give you a value, but it really starts out as a ratio. So I can write this as the inverse tangent. It probably came from -1/2, negative square root of 3 over 2. That was probably the ratio that we started out with. And that's exactly what it is. So what is this angle over here? It's either a pi over 6 or a pi over 3. Which one is it? It's a pi over 6, isn't it? And it's actually, what, 7 pi over 6? 6 pi over 6, 7 pi over 6. Now, I can't do that with 3/4 with angles with values that I know. I don't know what 3/2 and 4/2 is. We wouldn't be able to do that one. All right. Let's practice this. Change this r equals 6 cosine to rectangular. So it kind of repeats. We're just practicing it now. All right, this first one, we got to get one of the tools. Well, we're going to multiply both sides by r. So r squared equals 6r cosine theta. And we see one of the tools that we have, r cosine. Then we can go x squared plus y squared is equal to 6x. So we minus 6x. Whoop, not 0. I was thinking 0 on the other side. Plus blank. Plus y squared is equal to 0 plus blank. I got ahead of myself there a little bit. 6 divided by 2 is 3. 3 squared is 9. So x minus 3 squared plus y squared is equal, got to add 9 over here, is equal to 9, and there we have that circle. But we knew that was going to be a circle, and we're going to push it off to the right. 1, 2, 3, 4, 5, 6. So there's the circle right there. There's the center. Cosine's x, pushing that thing off to the right, along x. Two over cosine. Students are tempted to multiply both sides by r on this one, but that's way too hard. This one's much easier than that. Not when it's secant and cosecant. We just change it to cosine, multiply by cosine, and we got it. It's x equals 2. It's a vertical line. So you'll be tempted to multiply both sides by r there. We don't do that. We don't do that. Too hard. This one and this one are almost exactly the same. We did one step for you. X squared plus y squared is negative 8x. X squared plus 8x plus something plus y squared is equal to 0 plus something. So x plus, 16, right? 8 divided by 2 is 4. 4 squared is 16. There's another circle. But it's down, right? It's really negative 8 cosine. To the left. Excuse me, to the left. The one off to the right, you guys, this one's a little different in that we just multiply this over, and we get r sine plus 4r cosine equals 10. I'm always looking for those tools. How can I get those tools out of this? How can I get an r squared? How can I get an r cosine? So this is just y plus 4x is equal to 10. Forget about that last one. It's kind of dumb. It's weird. All right, today, we're going to just practice those. Should be a pretty straightforward assignment for you. We are right here, 10-3. 10-3, we'll graph them. Guess what we're going to do on Tuesday? Look at that title. Slope and points of tangency. What do you think we're going to do to these? Take the derivative. What about February 2nd? Look at that title. What are we going to do to that? We're going to integrate them. You're welcome. Yeah, so we'll do the calculus on Tuesday and Wednesday on this stuff. Right now we're not doing any calculus. We got a wrap up, so we'll review. We'll do polar partner quiz, which is a little different, kind of fun. Review and test. So this chapter goes pretty quick. This is kind of an easy chapter. We go pretty quick with it. Then we get into infinite sequence and series, which is really long. That's a very long chapter. A lot of stuff in it, and it's a pretty tough. We end on a pretty tough chapter. So you got that to look forward to. All right, that's what I got for you. There you go.